Okay, y'all, let's get started. So I will have the exams for you by Thursday. I was hoping to have them today, but I worked till midnight on them last night and there were still 4 hours, and I can't, unfortunately, go on about 4 hours of sleep. And probably grading after 12 midnight would have been pretty error prone anyhow. But I will have them for you on Thursday. Probably your grades will be up sometime tomorrow evening, I would say. And I will go over the exam as well on Thursday. Also a reminder for graduate students, if you haven't started the graduate student project, at least start thinking about it. I know it's not due until November 12th, I believe, but it's still due in about 2.5 weeks, so you want to start thinking about it. Okay, and we will be this week finishing up Perl. Hopefully you are studs and studettes now at regular expressions, and you'll get better because you'll be doing that a lot through the rest of the semester. Today, we're going to be moving on to talk about functions in Perl, file handling in Perl, and sorting in Perl. And then on Thursday, we'll be talking about that abomination called objects in Perl, because Perl has one of the most, shall we say, creative and unique object systems that I have ever seen in my life. It was kind of slapped together when object programming became more popular. Okay, so we again will be talking about version 5 of Perl. Version 6 of Perl is going to be fixing some things, both with objects and with functions, but all of this is going to be version 5. So, getting going, with functions, you introduce them using sub, which stands for subroutine, which is a very old nomenclature in computer science. You give the name of the function, say max, and then it takes no, or appears to take no parameters. So you can't declare formal parameters in a function, yet you can access an argument list. So there is a variable called @_, which is the list of arguments for the call. And you can unpack those arguments by, say, you could do this, $A, $B, $C equals @_, and that would take the first 3 items from that list of arguments and assign them to A, B, and C. If the list was not 3 elements long, if it was only 2, then C would be undef at the end of it. Conversely, if there are more, then those will simply still be out there. If you said instead $A, $B @C equals @_, then the first 2 elements of @_ would be assigned to A and B, and all of the remaining elements of that argument list would be assigned to C. Now, a thing about Perl that's annoying is that any variable you declare in a function is actually put in the global namespace. So what I just did would, let's say I said $A, $B equals @_. $A and $B will actually now be placed in the global namespace. So to see that, What? Going to write a quick function for you. So we'll just call it sub anything, and we'll assign a b gets at underscore. That's all we'll do. Now we will call sub with the values 10 and 20, and now we will print $a. Yeah, you're right. I'll fix that. Thank you. So what's great about having people looking at it. Okay, so if this was C, what would you expect to get for those print statements? Would it work or not? It wouldn't. It would say that $A and $B were undefined in the current scope. Okay, watch Perl take a whack at it. Well, what did I do wrong? Print is right, anything. For main. Pardon? Yeah. I'll try that. That's, oh. Yep, thank you. There are supposed to be no parentheses even. I will take that back. So you can see that A and B are defined. They're actually put in the global namespace. Okay, so that's not good. Let me get rid of my parens here. So no parens. So if you want to only declare $A and $B to be local, you use the my keyword. Okay, that's an odd keyword. You might think, why not something more logical, like, for example, local? Well, it turns out that, in fact, there is a keyword local that will also declare your variables as local variables, and they will go out of scope when the function exits. However, if you use local, your locals will be dynamically typed. And if you use my, then the locals will be statically typed. Can anyone tell me the difference? It may not, for those of you who took 365, we might have covered that. Okay. Nope, that's a good guess, but it's not. That's a different definition of static. So there's the C definition of static, which would mean the values would still be kept around, but that's not actually static and dynamic typing. So statically typed means that when you access a variable that is not declared locally, it will determine its value of that local by looking at enclosing procedures or scopes. So in Perl and in C, the enclosing scope could first be an object if you have a class, and if it's not an object, then it could be the global namespace. So locals that are statically typed means if a local or if a variable is not declared locally, we search for variables, a variable with that name. In, I'll call it enclosing namespaces. Like I said, with C++, if you have a method, you access a variable that's not declared locally. What is it going to first try to, where will it first try to find that variable's value in C++? If you don't, if I have a method, say I have a class foo, C++, and I say, and I have a method void x, and I try to print y, and y is not defined locally, what will it try to first look for y? As a member of the class. It will see if it's an instance variable of the class. So that's the first enclosing namespace. If it doesn't find it as a class member, what does it now look for? Yes, so if it's a nested class, then it looks into the parent class. If it's not in any nested, if it's not in any parent classes, where does it next look? There's one more. It looks into the global namespace, checks to see if it's a global variable. Okay, so that's static typing. If a local is dynamically typed, then what happens is that if a variable is not declared locally, we search the call stack and choose the topmost stack frame that contains a variable of that name. Okay, so have an example. Let me move this over so if you're copying, you can still copy. So here's a very simple program. Globally, I set $x to be 50. Then, in subroutine or procedure H, which worked. This is weird. Just a second. Why the parentheses worked there beats me, but they did. Pardon? Ah, really? So that's such a bizarre thing, though. Okay, so at any rate, in H, I declare a local variable x using my, and then I call g. In G, I print the value of x, and then here at the top level, I call h. So this is going to behave like you expect, which is that what value do you think is going to get printed for x here? 10? Really? If this was C, you really think this would be 10? Because if you're looking at enclosing namespaces, there's nothing that G is nested in, so it's going to go straight up and look at this global. Okay, so it's actually going to print 50. And that's what a C program would print. Now, same program except that I declared x to be local rather than my. Otherwise, the two programs are identical. Okay, now when I run it, x is 10. Okay, what happened? Well, here's the call stack. H, then G was called, and down here x is equal to 50. Well, H declared an x that is 10. So here, because this was declared as being dynamically typed, when we go and try to find the value of x, it goes searching down the call stack and it finds $x there and it prints 10. William.
Back to the earlier question about parentheses being required.
Mm-hmm.
In this case, you aren't passing these arguments. So when you provide the parentheses, what you're providing is a artifact for the function.
Mm-hmm.
So if you try to pass a value into the call H down here, pass an argument, you will pull that.
Really?
Unless you put a dollar sign in each of the values. You can tell what
Interesting. Okay. I'll have to look into the difference between prototypes and that seems like a kind of odd quirk.
you're providing basically having the arguments that you expect.
I see. So by putting the left and right parentheses, I'm in effect saying it takes no arguments. I see. And by leaving it off, I'm in effect saying it takes arguments. It's okay. Demi.
Okay, I was just saying that a lot of people think that using the parentheses, using subroutine prototypes in Perl is a bad idea because it can lead to confusing. It can get confusing and.
Well, you could see that just now. I got confused. So.
It doesn't actually work the way say a function prototype in C works.
Mm-hmm. Yep. Believe me, I just found it confusing. So, okay. So thank you, William. Thank you, Demi. So at any rate, do we understand the difference between dynamic and static typing? Does this make sense? Yes, Demi.
I mean, typing or scope?
Ah, thank you. Yep. I should have said dynamic scoping. Locals are statically scoped. Thank you. That was wrong. Dynamic typing is different. So this statically and dynamically scoped. Please make that change to your notes. That's important. Statically and dynamically scoped. Okay. Dynamic scoping. So back in the 80s, it was still kind of an open question among people designing languages as to whether static scoping or dynamic scoping was superior. By the early 90s, it had been decisively resolved in favor of static scoping. Dynamic scoping, like go-to statements, was considered dangerous. And the reason dynamic scoping is considered dangerous is that you might be writing a piece of code and you assume that when you write G that you're going to be called from H and that you will have H's definition for X. But let's say that in fact there was an intermediate function sub J which calls G and H calls J. Okay, and some programmer comes along and decides they need to do something. So they, not knowing that G depends on H's definition of X, come into J and declare $x equals 30. Now what happened? Your code breaks mysteriously. You're maintaining this code, okay? So you had no idea that the original programmer designed the code so that G would be using H's definition to $x. As a maintainer of the code, you just naively come in and you need a variable, you need to do some computation in J, and you naively create a variable called $x. You have it do something, and now all of a sudden the code breaks, and you're just looking at it, and all you're doing is looking at J, and your code is perfectly written, nothing's wrong, but the code no longer works. And the mystery is that actually the problem is down in G. G is now getting J's definition of X rather than H's definition of X. And this caused such baffling errors in production programs that by the early 90s, just like GoTo's, dynamic scoping was considered harmful to your health, okay, or harmful to a program's health. However, Perl was designed in the late 80s when this debate was still an open issue. And Larry Wald chose dynamic scoping. So when he defined the local keyword, he made it be dynamically scoped. Well, when it became clear that static scoping was the way to go, the Perl standard needed to be changed, but you couldn't very well redefine local to be static scoping. Why? You'd break all the legacy code. Okay, so you can't do that. You can't just, well, you can, but you'll make a lot of people very angry. So they couldn't very well redefine the semantics of local, so they introduced a new keyword called my, and that is why if you want to have a statically scoped local variable, you use my. It is also why you should always use my and not local. Dynamic scoping is a very dangerous strategy. It's also very alluring, okay? I used it when I was a postdoc in the late 80s, and I thought dynamic scoping was the greatest because it allowed me to do some marvelous things, okay? It also later on caused some of my code and other people's code on the project to behave in a squirrely way for exactly the reasons I laid out. Okay, so just make sure, because there could easily be a question about static versus dynamic scoping, that you understand the difference between the two. It's important, even though dynamic scoping is almost never seen in modern languages. Okay. What else? Okay. If you want, you can also get access to parts. You don't have to say, in a second. You don't have to say my $$A$B equals at underscore. You could simply say this as well. Okay, and this would access the first element of the argument list. So that's just treating the array as a scalar. Now, another thing about Perl. Let's say I want to write a function that's going to sum two arrays. Okay, so here's my code. All I want to do is I want to pass two arrays, so I created two arrays here. Okay, and now I pass them to sum arrays. And what I expect to get back is an array that does a pairwise sum. So what I expect to get back is 10 plus 40 is 50, 20 and 50 is 70, and 30 and 60 is 90. So this is what I expect to get back. Okay, so I'm passing these two arrays. And up here, in sum arrays, I unpack them from the argument list. declare two variables, I and my list that's going to be summing. Then I run I from 0 up to the size of the first array, and I push the sum, the pairwise sum, onto @sum. So this is how you would write it in C. Obviously, the syntax would be a little different, but that's how you would write it, and you get 50, 70, 90 in C. In Perl, this will be your output. 10, 20, 30, 40, 50, 60. You're thinking, what the heck happened? Okay? So what happened is that when you pass an array or a hash, it unpacks the elements into a list. So in fact, what this really was, you were passing to some arrays a single list that looked like 10, 20, 30, 40, 50, 60. So it's like interpolation. It simply takes whatever are the contents of the array or the hash and interpolates it into the argument list. So when it got here and it saw my @A, it gave everything in the list to @A. So @A was set to the entire argument list, and there was nothing left for @B, so it was given the value undef. Okay? And Perl is very clever about doing casting. So it did not give you an error for saying $B, $I. Instead, since $B is undef, it just treated the whole thing as 0. So it added 0 to each of these, thus coming up with the same list. And when you returned it, you ended up coming back with 10, 20, 30, 40, 50, 60. There needed to be a return statement here. I will add that. There should have been a return @sum. I will add that. Okay, so that's no good. Clearly, we want to be able to pass hash tables and arrays to functions. And the way we do it is through references. So the right way to do it is to pass the address of those two arrays to our function. We now unpack the scalars, which are 2 pointers effectively, and now we dereference them and get the right result. Okay, so you already saw one use of references for creating records from hash tables. This is the second reason we use references in Perl, to pass arrays and hash tables to functions. So it's important enough that we will write it down: to pass arrays or hash tables to functions, we must pass a reference to that array or hash table. Okay? Once you understand that, life is good. If you don't understand that, life is hell. Okay, so questions about functions. Otherwise, very much like C++. I guess one other cute thing is that you can return multiple values via a list. So here's a cute one. That's just defining a function max that's returning. Actually, that's not what I wanted. Where do I have unpacking? We don't have it. Okay, so let's say I want it to return two values, a max min. So let's say I had a function called sub max min, or min max, doesn't matter. And we set my $A $B equals at underscore. We might say $max equals, let's see, yep, $max equals A less than $B, question mark, actually make it greater than, return $A, otherwise return $B, min equals $A less than B, question mark, $A, $B, return min max. And this returns a list of the two values, which can then be unpacked on the calling function's end. So that's a cute thing, because oftentimes in C, C++, Java, we want to return multiple values from a function, and we have to use reference parameters or pointers, whereas here we can just return a list. Then the other advantage to having variable argument lists is that here we actually are declaring a max function, and it can compute max for an arbitrary number of arguments. So we just, first of all, check to make sure that we have at least a list of one element, set our max to be the first element of the list, iterate through the list of arguments, and we find the maximum argument and finally return it. So Perl makes it easy to handle variable-sized argument lists. So those are the features of Perl functions. Questions? Okay. So moving on, we already talked briefly about standard in, but obviously you want to be able to manipulate files. One of the whole purposes of Perl was being able to extract information from files. So being able to manipulate files is obviously important. So the important details about files. First of all is their naming convention. They tend to be all caps by convention, not by requirement. And secondly, they have no prefix. So other variables have a prefix like $, at, pound, but file handles typically do not. Yes?
In modern code that uses the use of file handles that are of that form is discouraged, it's preferred to use ordinary scalar variables that are prefixed with a $sign, and you can, and anywhere that you can use, a Bearwood file handle in any function that creates it, or in any built-in function at least, I think, and in almost all other functions, you can pass just a local variable,
Right.
to become a reference to it.
Right. I think what you're referring to is, if I'm not mistaken, this. No? Okay. Well, Demi, we'll cover it later. For the time being, I'm going to do it my way, and we can chat afterwards, because the way I learned it, and I guess the way I still do it in my code, is this way. So That's fine. I know how to do it my way, and your way I would have to figure out. So the way I have always done it and still do it is I use all caps and it has no prefix. Okay. If you use a different naming convention, I'm not going to be upset as long as it works. Okay. So there's two forms of the open. There's pre 5.6 and post 5.6. So pre 5.6, version 5.6, it was open, you gave it a handle name and a file name. And you'll notice here there's no way of telling, just from what I did, whether it's read, write, or append. Post 5.6, it was open, handle, mode, which could be read, write, append, and file name. So mode is read, write, or append. Now that was before 5.6. You could still specify the mode. The way you did it was by putting an arrow in front of the file name. So by default, it was open for input. But if you put a greater than sign in front of the file name, it opened it for output. And if you put two arrows in front of the file name, it opened it for appending. And typically, you didn't put anything in front of it if you wanted it for input. Okay, so post, you still put the mode like this. So if it's going to be read, it's that. If it's going to be write, it's that. And if it's going to be append, it's that. So you still use a string to denote the mode, but now the file name is separate. Almost all Perl code is now run post 5.6, but if you're absolutely not sure about it, then you can put this directive in. And what that says is that if you are not running an interpreter that is 5.6 or later, then the interpreter should print an error message and return, because it won't otherwise handle it properly. And I'm not sure, I once read why the double zeros are there. I don't remember off the top of my head anymore why the double zeros, but it is what it is. So I think it's because they also, if it's 5.10, it's that. So I think it's actually just has to do with version numbers, that they can go up to 999. So if you're just not sure that, if you want the absolute maximum in portability, if you're using that feature, you can put that use statement in there. Okay, and you can see that you can use Unix style expansion if you use angle brackets. Is that Greg? You'll probably tell me why, but let me just get to the let me get to the angle brackets. So the angle brackets are going to do Unix style expansion for you. Pre 5.6, you could only do that with input files. You couldn't do that with output files, because pre 5.6, if you gave this as a file, it would interpret this character as saying it should be input. And it would think that your file name started like that. And you'd get some kind of gobbledygook. So that didn't work so well pre 5.6. But if you want expansion, and that's dangerous because you're pretty much assuming that the file will be at a particular place in the file system, which obviously tends to make your code a little less portable. Greg.
Is that a three-argument version for input as well?
You can,
Is the only specific I mentioned?
yeah, sorry. It's you can also say less than, and it will do the trick. So there is a three argument version for input as well. Okay. And once you've opened the file handle, you can read from it by putting the handle name into quotes. Not quotes, angled brackets. So this will read a single line from that particular file. And if it fails, it returns the value 0 to indicate that it failed. Okay? If you are writing to a file, you use print, then you give the handle name, then you give the string that you want. And does anyone notice something odd about this? So if I want to write to say foo, hi Brad, anyone notice something unusual? There is no comma between the handle and the string. So don't put a comma there. What do you think happens if you put a comma there? Greg? It prints foo, or whatever it thinks foo is, the value of foo is, to standard out. Because the general form of the print statement to standard out is print x, comma y, comma z, where x, y, z are various values or variables. So put a comma there, and it'll just think you want to print to standard out. So you can't put a comma between the file handle and your string. Of course, if there are multiple strings, you can. So then after this, if I had more strings, I could in fact say, so it's only between the file handle that you don't have your comma. Okay, and of course, open may fail. So there are a command called die and warn, which you can use. This is kind of idiomatic. So open could fail for a number of reasons. You don't have permission to access the file in that mode, or the file doesn't exist, or there could be other reasons. So this idiom is if it fails, or die. Die kills your program and prints whatever string you have. The $bang prints whatever the system error is. So it's the same. So $bang prints whatever p error prints in C++. Or in C. Okay, in other words, it's the system, whatever system error occurred, that message will be printed by $exclamation mark. And die has some quirks. Notice there's no new line here. Okay? It will still put a new line at the end of the output. It will, with no new line, it will print the line at which the error occurred, and the name of the file. So here, it said no such file or directory at temp.pl line 1. So without a new line character, it prints the name of the file or the name of the script and the line number. If you put a new line character at the end of die, it will suppress that information. So, quick, call it error.pl, open BVZ or die, could not open BVZ, $. Okay, so here I did not terminate it with a new line character. Okay, and it says at error.pl line 1. Now I will terminate it with the new line character. And it suppressed the name of the script and the line number. And there's a convention for when you do and don't. So if it's a system error, defined error, print the line number. Script. And line number. If it's a user-defined error, you don't. Okay, and the reason is that if it's a user-defined error, it's something like, say, did not provide enough input, or value should have been an integer, not a string, and the user doesn't need to know what the line number is. Okay, they just need to know what their problem was so they can fix it. Where if it's a system-defined error, often there's something wrong with the program that has to be debugged, not always, but often, and the programmer wants to know where the error occurred, what line. So that's the rationale. Okay, and finally, there is a close command. So if you say close handle, it will close the file. Although it will leave the variable defined, which is kind of odd in my opinion, but it doesn't. So even though the file is no longer, handle name is no longer associated with the file, if you ask if that variable is defined, it will say yes. Just a word of warning. So questions about files. Okay. So the last thing is sorting, because that's a very common thing to want to do. And it's very easy. You sort a list. And it does it in alphabetical order, whatever that may be. So very handy things. It's very easy to sort a file because a file is actually can be treated or handled as a list. And you can go in reverse alphabetical order. You might think this is inefficient because it sorts it and then reverses it, but Perl interpreters use tricks. So actually when they see the word reverse sort, they actually just sort it in reverse. They don't actually first sort it in ascending order and then reverse it. However, this doesn't work well with numbers. So here's a list of numbers. You sort them, and this is the result. Can anyone tell me why that is the result? Pardon? Alphabetical order. So 1 comes before 2 in alphabetical order. Okay, ASCII code for 1 is less than the ASCII code for character 2. Therefore, 200 comes at the end of the list. Kind of inconvenient. So if we want to do numeric sorting, we use something that is called the spaceship operator. So called because it looks a little like a spaceship. And what that operator does is it returns one of 3 values. It returns a value less than 0 if $A is less than $B. It returns 0 if $A equals $B. And it returns a number greater than 0 if $A is greater than $B. I suspect in many cases it simply subtracts the 2 numbers and returns them. You'll also notice the curly braces here. Okay, the curly braces is defining an inline anonymous function. This inline anonymous function, in Perl, these 2 variables are predefined for you. Not in every anonymous function, but for sort, these 2 locals are predefined. You don't have to define them yourself. Okay, also sort returns a copy. It doesn't do in-place ordering. So if you want notice here I had to assign the result to @A, and the reason is sort does not do in-place sorting. It creates a copy and it returns a copy of the list. Okay, sometimes you want to do this kind of comparison for alphanumeric data or for alphabetical sorting. CMP does the same thing for alphabetical sorting. So here I have a list and I want to sort by last name, and then I want a secondary sort on first name. So for example, there's 2 camels there. Therefore, Aaron should appear before Joe in my result. Okay, so hopefully you watched the video lecture and you know that you can split a string using the split command in a regular pattern expression. So I'm doing that first. Then I'm checking to see if the last names are equal, because the last names are the second item. If they are, I return a comparison between the first names. And if they're not equal, then I return a comparison between the last names. And again, notice this is all an inline anonymous function. Everything occurred between the curly braces. Actually, all the way down to here. And also note there are no commas. So there's no comma between the anonymous function and the list that I'm sorting. The reason is if there was a comma, then Perl will assume that you want a list. That is, it would assume that this gargantuan thing is one of the data items to be sorted and should be prepended to @A, not exactly what you want. Therefore, don't put commas between your function and your list to be sorted. Okay, and that's kind of a lot to put into a sort statement. So you could alternatively create a separate function. In this case, I called it compareRex, and do the same thing. And you'll notice that I did not declare $A or $B to be local variables. That's again because when they're called by sort, they're supposed to be predefined. And then down here, I just give the name of the function. So, questions about that? Okay, so here's a couple other neat examples. Here I'm sorting names and I don't care about case. So the \L converts everything in that string or in that variable to lowercase. So when I compare Brad and Frank, they've been converted to all lowercase characters before I do the comparison. Okay, and this example is sorting employee records. So in this case, I'm assuming I have a hash table. I'm assuming that in the hash table, there is a name value pair. And I assume that I am sorting the records according to that name. So here I'm getting two references because I have a list of references to hash tables. And you can see I'm using the compare to do the comparison on the alphabetical comparison between names. And then here I'm simply going through my records, printing it out. Okay. So there you have it. Functions, files, and sorting. So questions about any of those? Questions about what I covered in the video lecture with regular expressions? Was there anything there that was confusing? Especially the split command. The split command is a really valuable command. Nope. Okay. That case lets you go early today. Thursday, we cover object-oriented programming, and then we move on to PHP.